All right, we're going to get started. Good morning, everybody. My name is Iana. I'm going to be the talk monitor in this room this morning. So if you have any questions, feel free to grab me. I'll be sitting in the back. And I'm going to introduce Steve Reinert. He's going to do our first talk, and he's from the Saltmarsh Sparrow Initiative. So I'll let him take over.
YouTube has 20-minute times. I can keep tracks. My talk's about 20 minutes and 30 seconds. But Iana told me she'll give me she'll let me run over. But I apologize ahead of time if I can't cram all the information I want into and I have to hurry to the last few slides. Good morning. I'm very pleased to be able to present the first 5 years of our Saltmarsh Sparrow research in Warren, Rhode Island. I'd like to introduce David Robinson, and who will be presenting next with Joel. And is Jim in the room?
Let's see.
My other partner, Jim O'Neill. Also serves as the triumvirate that runs Saltmarsh Sparrow Research Initiative. So on we go. Sarah, yeah.
So that working?
Not advanced.
And it should be. Point at the computer. Can you close it up? So I get it. Right now. There you go.
Okay, I want that time back. Freshman. Okay. So our study site is Jacobs Point in Upper Narragansett Bay, Warren, Rhode Island, about less than half a mile to the east of Homestead. And the marsh formed behind a narrow sandstone barrier. Its line to the east is the East Bay Bike Path. It's bordered to the south by this road bed. It's culverted here, a little bit of salt marsh, and then about 15 acres of uninterrupted Phragmites. So I'm going to give some Saltmarsh Sparrow basics. Not that you all need it, but some of you may. So Saltmarsh sparrows nest exclusively on the high marsh and above a certain range of elevation. 3/4 of the nest were built in these salt meadow species, and then the remainder were split between mixtures of these grasses with high tide bush at the higher elevations of the marsh, and then these grasses with cordgrass at the lower elevations of the marsh. During the breeding season from May through August, once per month, lunar-driven flooding tides invade the marsh, cover all the habitats, including all of these habitats at the Saltmarsh Sparrow nest. What could go wrong? This is a Butch Lombardi drone photo of Jacobs Point during an extremely high tide. And a tide of this magnitude would cover every nest on the marsh and destroy probably all of them. Because of these environmental extremes, few bird species have adapted to be obligate nesters in the salt marsh environment. And these are the 4 in the Northeast: Copperrail, Willet, Seaside Sparrow, and Saltmarsh Sparrow. And of the 4, the Saltmarsh Sparrow is most vulnerable to sea level rise for 2 reasons. First, because of its very restricted breeding range. So it nests only from Virginia to Maine in all of North America. And secondly, because this breeding range coincides very closely with the region of greatest sea level rise rate in all of the contiguous United States. So it's kind of a double whammy, which is why this bird gets the moniker of an indicator species, the salt marsh health, and for the health of other salt marsh obligate bird populations. So we know that range of sea level rise from this report put out by NOAA in February 22. Also from this report, we know that in the 14-year period beginning 1998, when saltmarsh sparrows were exhibiting a 9% decline in relative abundance and 12% in New England, that a sea level rise threshold was crossed, beyond which the frequency of high tide flooding increased. And those high tide flooding events would be of an elevation to cover the nests on the marsh. So it's kind of a perfect storm developing, not on the favorable end of things if you're a saltmarsh sparrow. A lot of talk about flooding in saltmarsh sparrows. We can't forget about predation as a mortality factor. I put together 7 of the largest studies conducted on the species, and in 4 of them, more than a quarter of nests were lost to predation. 2 of those in Rhode Island, in Galilee, and our study in Warren. And 2 of those also had high levels of flooding, one of those being our site. So when you take all of this rather depressing negative data about saltmarsh sparrow populations and you plug them into statistical models that scientists have done, these are your results. We get these predictions of extinction. One from Connecticut here as soon as 2035, one from New Jersey where predation is a principal mortality as soon as 2050, and we'll come back to that. We'll come back to this Chris Elphick quote later in the talk. So now we're going to refocus on our study and our results, and we're going to compare them to other studies, range-wide studies in the present, and that's the period I'm calling the present. Then we're going to look back as far as 4 decades in the past and compare our results to what was happening in the past, both Narragansett Bay and otherwise. Then we go back to the future. So Narragansett Bay. Narragansett Bay is understudied as far as saltmarsh sparrows go. It's a very large estuarine system. Ours is only the 2nd comprehensive study that's been performed there. And we will look at the other ones. So in the present day, we're going to look at 3 measures of reproductive success. The first is crude nest success, simply the percent of nests that produce a fledgling. And at Jacob's Point, less than a third of the nests, 234 nests monitored, produced a fledgling, and the remaining succumbed to flooding and depredation. More than twice as many succumbed to these stressors as were successful. And flooding was the dominant stressor. Now we look at a second measure, daily nest survival probability. This is a fancier calculation than crude nest success, and it controls for a bias inherent in the crude measure, the discovery days bias, which would take me 20 minutes to describe what that is. So we skip over that, and the point of this slide is that our value of 0.926, and this was calculated by Kate Ruskin, and we thank her very much, and she's at the University of Maine. Our value is right in the middle of the 2 other values calculated range-wide for the species. And our third measure is fecundity. This is a measure of productivity, and it's the number of young fledged per female per year in the saltmarsh. So our value of 1.39 is close to the range-wide value that Kate Ruskin calculated at 1.27. So for both of these measures of daily nest survival probability and fecundity, we're right in the ballpark of range-wide measures. So I add one more piece of data from Jacob's Point. To 2022, when 60% of 68 nests were lost to flooding, and we had the overall lowest nest success of any of the first 5 years of our study, at only 19%. And so we're kind of mirroring the Long Island Sound results of Connecticut researchers, which are not good. So when I put all of this information I just presented together, I find no evidence that the populations in Narragansett Bay vary considerably from the declining trends that investigators have found region-wide. So it's not great news. This talk is not an antidote for what you heard earlier this morning, I'm afraid. So now I go back in the past and I introduce my friend William DeRagan, who I stopped the marshes with 4 decades ago. And William passed in 2019. William conducted intensive studies of Saltmarsh Sparrow ecology in 4 Narragansett Bay marshes, above and below ours here. And I thought, what an opportunity to compare our results in the present day to what happened 4 decades ago. And so I looked at several things. First thing I wanted to look at was, were the elevations of peak tides then different from now? And so to gauge that, I used the tide gauge here. It's a NOAA tide gauge. And I compared the elevations of June and July peak tides from that tide gauge. And this is the result. The result was an 11-centimeter difference. And that looks like this red band here. You can see that. And so the Saltmarsh researchers in the room, and there's a lot of them, know that this can very well make the difference in a successful nest or a failed nest. And so this is a bit of a dramatization. However, in the past day, this 11 centimeters enabled this bird to climb out of the nest into vegetation that was not flooded and survive. And in a dramatization in the current day, that nestling may well have drowned for lack of vegetative substrate to climb into. So, whereas this is more of an anecdote, this is a statistically relevant sample. We look at the nest outcomes from 4 decades ago relative to now, and we see that nearly twice as many nests successfully fledged young 4 decades ago. The depredation rate was also substantially different, substantially greater during our years, and also the percent of nests flooded. And this value here would expand to probably 50% if we only experienced 5% depredation. Speaking of depredation, Jim O'Neill led a camera trap study in 2022, placed motion sensitive cameras at 35 nests, monitoring day and night for several days at a time. And we were able to identify the identity of only one nest predator, the white-tailed deer. The first time it was discovered, and we had 2 incidences of white-tailed deer eating eggs out of the Saltmarsh Sparrow nest. And that was written up by John Herbert. You can find it in Northeastern Naturalist. And this disparity makes me wonder, because when you think about the difference in number of deer then and now. Okay, still back in the past. Now we're going to look at daily nest survival probability. So the historical nests are shaded in green, and they date back 2 and 4 decades. And the current period, the more recent period, are these 3 measures. And you'll see there's consistently higher nest survival in the older periods than in the current period. And so now, again, we look at fecundity, even a more dramatic difference. I could only find one old measure from Poston Greenlaw back in 77 to 80. And their fecundity values, again, number of young fligs per female per year, were more than double that of recent calculations, both for Narragansett Bay and range-wide. And so the Greenlaw, the author, included a reduction in reproductive success over those 4 decades. So here's William, and this is a reminder for me to sum this up. So let me go back farther in the past, we again see more evidence of greater nest success, greater reproductive success historically than we're finding now. And so it matches with the previous results we've seen from other investigators. And so now we move to the future. I'm going to refer again to the NOAA report from 2022. And now to make projections into the future, we need data estimates from scientists. And so the NOAA scientists have come up with projections. And so if we compare their 2020 projection with 2050, actually their 2020 data with projections to 2050, we get a 27 centimeter difference, 5 minutes. So this is the Cliff Notes version of breeding windows. I could do 20 minutes on this slide very easily. Okay. So we have nest elevations in red and daily tidal elevations in the black dots. And at Jacob's Point on June 12th in this scenario, a new moon tide floods the marsh, lunar-driven tide floods the marsh, destroys all the nests. About 15 would be active at that time, resets them all to 0, and they're all synchronized now in their nesting activities. 15 females, all immediately rebuilding nests. The nesting window is the approximately 28-day period between these monthly flooding events within which the Saltmarsh Sparrow must compress or must complete its nesting cycle for that species to thrive on the salt marsh. In this case, it's very close, 3 fledge, 1 drowns, and those fledglings had to climb out of the nest to survive. They were about 9 days old out of a 10-day nesting period. For this window to work, 2 things are required. One is an immediate re-nesting response of the sparrow, which is an adaptation. And secondly, the intermediate or alternate phase full moon tide in this scenario the elevation of those tides must remain lower than the nest elevation, or we lose the window. 27 centimeters. We added 27 centimeters projected by NOAA to our earlier scenario, and now we've violated our second assumption that the alternate phase tide now inundates nest. We lose the nesting. Reproduction becomes nearly 0 in this scenario. Not only that, the window is shrinking from each side as well. Okay, so what I just showed you is represented by this chart. And Chris Elphick states there's a threshold point beyond which extinction could happen very quickly. Okay, here it is. So each marsh will have its own threshold tidal height at which the nesting window disappears and productivity plummets. And that's the extinction point, 2 minutes. Okay, so it looks bad, but still reason for hope and action. I'm going to put this slide up when I end the talk so that you can take a little time to review it. Right now, I want to review our one finding of our report that was different from anything else in the literature, and that was the finding on high tide bush. So that's one of the 3 habitats I displayed earlier, and here it is here, this shrubby habitat that occurs at the higher elevations, the highest elevation within the salt marsh. And how does that height translate to nest height? We can see here, this is high tide bush, Agaphytessins. The elevation of the nest rims of nests and high tide bush was significantly greater, 10 centimeters greater than for nests in salt meadow. And the outlying values, in other words, for the sparrow, some sparrows built their nests very high in the vegetation, minute and 11 seconds, very high in the vegetation. That's as high as 52 centimeters above the mean elevation of the salt meadow. That's a foot higher than the mean elevation of all nests combined. So the potential is here for sparrows to leverage or use this higher habitat. These nests were always successful, these high ones. They actually avoided being drowned and provided appropriate nest cover to protect the nest from predation. When we look at the outcomes, we see here that the crude nest success was double that, nearly double that in high tide bush. I'm wrapping up now. Nearly double that in high tide bush relative to the other habitats. Less than half of the high tide bush nest flooded relative to the lower elevation grassy habitats. And the predation rate was about the same. And the number of fledglings per nest was double that of the other habitats. So, but they occurred with the same, they were selected for, 11% of the nests were in high tide bush, and 11% of the marsh was covered high tide bush. They're not being selected for, and we can't train them to use the high tide bush. But what we can do is increase the percent coverage of high tide bush on the marsh. They're experimenting with raised hummocks in Great Meadows in Connecticut, and their experiments don't incorporate IVA. But one of the suggestions from our report will be that such experiments include IVA, so that we can gauge it as a potential conservation measure for salt marsh sparrows. And I thank you very much.